this video is going to focus on the theorems that we learn in grade 12. And the first one we're going to look at is called the proportion theorem. And this is how the proportion theorem is described. A line drawn parallel to one side of a triangle divides the other two sides proportionally. So if you look at this sketch here, we are given a line that is drawn parallel to one side of the triangle, and then the sides are divided. Okay, so essentially what we're dealing with is we have generally one big triangle, okay, and then a line that's drawn parallel, which creates, in essence, a smaller triangle inside of that big triangle. And you just need to read your questions carefully, because either they're going to give you the proportion of the segments within the big triangle divided by that parallel line, or what they could do is they could say, oh, this side here in proportion to the whole length of the triangle. So read the questions carefully and make sure that you don't miss out on these important details, because if you grasp that part, it's actually quite a nice section to do and to do well in. The best way to check our understanding is to just practice with some examples. So let's have a look. In triangle FGH, we know that FG is equal to 28 centimeters. So this whole length here is 28 centimeters. Then FJ to JH is 4 to 3. So what this is not saying, and be careful here, grade 12, they're not saying this is 4 centimeters and this is 3 centimeters. No, no, no. What they're saying is this is proportionate. So for every 4 centimeters that this side has, this side here will have 3. And so what is helpful is if we just say, okay, well, I don't know how many groups of centimeters it's going to have. And so I'm simply going to say this is going to be 4x and this is going to be 3x. Just to help me realize that's not 4 centimeters and not 3 centimeters, but rather 4 times however many centimeters based on the proportion. Okay, and now the question is determine the length of IG. All right, so the first thing we need to do is we need to say, well, we've got the proportionality theorem here, and then we need to start applying it. Okay, how do I know we've got it here? Well, because I see this parallel line here, and so I know that my triangle is being divided, or the other sides are being divided in proportion. So we want this length here, IG. Let's start off and tell our marker that the proportion of this to this is going to be the same as the proportion of that to that. Okay, and so that we can do, we can write it like this, or we can write it as a fraction. Okay, so I'm going to do that. Fj over jh, yes, is equal to, and then I'm going to say fi over ig. Okay, and the reason there is one of two things. You can either say line parallel to one side of a triangle, or you don't need to say both. You can say the proportionality theorem, and then list the parallel lines. So ij is parallel to gh. Okay, either of those will get you your marks. And now we just need to work with this. Okay, so that means, therefore, that fi over ig is equal to 4x over 3x there. And I know that the full length there is 28. Okay, so I just want ig. This is my unknown thing here. Okay, and it really, however you want to work it out, you are so welcome to do that. But basically, what I want to do is I want to say, well, if this is divided here into sections, then I want the overall thing. I want to link it to this 28 that I'm dealing with. So I've got 4x and I've got 3x, and then in total, that's going to give me a full 7x. There is my 28 centimeters. So I think what we should do is we should adapt this, and we can rather say, instead of fi, we can say fg over ig, which I want, is equal to, and then we're going to say 7x over 3x. So I'm just applying the full length. Okay, because the sides are all divided in proportion, I am welcome to do that. Okay, and now I can substitute in my 28 centimeters over there, and then I can solve. So let's do that. 28 over IG is equal to, those x's will essentially cancel. So we could just say 7 over 3. Okay, I like to do a cross multiplying. So this one multiplied by that, and 28 multiplied by 3. So that's going to give me 7 times IG is equal to 28 times 3. So that's 84. And then eventually IG is equal to 84 divided by 7 gives me 12. And they've specifically given the units there in centimeters. So my answer will be in centimeters. Okay, so there I simply applied the theorem, and I knew that I could apply it to the full length. But remember what I was saying earlier, you need to read your question carefully and then adapt the information that you've got. Okay, here's another example for us to try. In triangle FAC, we've got loads of parallel lines here. BD is parallel to AE. Let's color code those. BD and AE. And then also in the triangle, but not parallel to each other, BE is parallel to AF. And then they give us a bit of information there. BC to AC is 5 to 9. Okay, so BC there, 5x to AC, that's the whole thing there, 9x. Okay, if AC equals 18 units, find the length of AB. All right, so this whole thing here is equal to 18 units. Okay, so logic there is already telling me that each x is going to equal 2 based on this. But let's solve it nice and systematically. Find the length of AB. Okay, so the first thing we need to do is we need to find the proportion here of AB. Okay, and that we can do by saying 5 plus how much will equal 9, and that is another 4x over there. Okay, and so now I can say, well, AB over AC, because that's what we've been given, is equal to 4x over 9x. Okay, and I'm going to say there the proportion theorem. And which parallel lines are we working with here? We are working with the yellow ones. So BE is parallel to AF. Okay, and now I can substitute in what I know. So AB over 18 is equal to 4 over 9 because those x's are going to cancel. Let's multiply both sides there by 18. And that's going to give us our answer there. So we can pop that on the calculator. 4 times 18 divided by 9 gives me 8 units there. Okay, so that was question 1. Now question 2, if CF is equal to 45 units, so CF, the whole thing here, 45 units, determine the length of DE. Okay, now what's great is that I feel like I have so many options because of these red parallel lines. I can say, well, this one would be 5 and this one would be 4, or 5 to 4 in terms of proportionality. But because of the yellow lines, I can also say, well, this one here would be 5 to 4 in terms of proportionality there. And I think I'm going to have to start off, although DE, the one I want, is linking to the red parallel lines, my 45 units, my information is actually about this full side here, which is going to have to link to the yellow sides. So let's try and write this proportionality using the information we've got. That 45 units is going to be the full thing. So we've got here 5 and here 4. So in total, we're going to have 9. Okay, so what I'm going to say there is CF. Well, let's take the side I want. I want CE. It's always nice to have the side you want on top. It makes your algebra a bit easier. Over the full length there, CF is equal to, what's the proportion there? 5y over 9y. Okay, so I'm just using a variable each time, just so that I remind myself this is not 5 units and 4 units. It's a proportion of the 45. 5 parts are going there, 4 parts are going there, 9 parts in total. Okay, so that's what I'm doing. And then that's the proportionality theorem. So prop theorem, and we list our parallel lines. It's the same ones, the yellow ones. BE is parallel to AF. Okay, so CE over 45 is equal to 5 over 9. And then we're going to multiply both sides by 45. And then we can work that out. So CE, that'll cancel. CE is equal to 5 times 45 over 9. Let's work that out. 5 times 45 divided by 9 gives me 20 units. Okay, why was I interested in that? Well, because actually the question is asking me to find the length here, DE. Okay, and in order for me to do that, I need to know something there involving those red parallel lines. So I want to work in this triangle here. Okay, and because these lines are parallel, the same proportionality applies, which is quite cool. Okay, so let's do that now. Now we're going to say DE, so we mustn't get confused now. We're not using the full 5 units anymore. Let's write the new units up here. X, Y, let's go with Z. So 4Z, we're not using that anymore, and 5Z there in terms of proportionality. Okay, the side I want there is DE. So DE over, I've got the full length there I worked out, so over 20. So let's make that over CE is equal to 4Z for DE over 9Z in total. Okay, proportionality theorem, and then what are the parallel lines here? BD is parallel to AE. Okay, and now those Z's will cancel. CE I know is 20, so DE over 20 is equal to 4 over 9. Let's multiply both sides by 20. Okay, and so then what we want to do is those will cancel, those 20s. And so it's going to be 4 times 20 divided by 9. And that gives us 8,88 or 8,89 when we round off. So DE is equal to 8,89 units. There we go. So that's proportionality theorem at its finest there. Then let's quickly revisit a friend or a derivation of the proportionality theorem, which is here the midpoint theorem. And that says the line segment joining the midpoints of 2 sides of a triangle is parallel to and equal to half the length of the third side. So basically, because this length here is equal to this length, and because this length here is equal to this length, we can then deduce that this and this side here, these are parallel, and this one is half as long as this one. Okay, so it's a special version of the proportion theorem because essentially parallel lines divide the sides in proportion, but the proportion now is 1 to 1. So have a look at this example here. We are given this triangle ABC, and within that a smaller triangle DEF. Okay, and now the question is calculate the perimeter of ABC, the big triangle. Okay, so what I'm hoping you notice straight away is that this side is divided in half, this side is divided in half, and this side is divided in half. Okay, so we've got the midpoint theorem everywhere. All right, and so what I think we should do is start off simply by saying that all the outside lines are going to be double the size of the inside lines, because that's what the midpoint theorem says. Okay, so let's begin there at the bottom. BC is equal to 2 times DE because of the midpoint theorem. Okay, this is actually a theorem we learned in grade 10, but I know grade 10 was a long time ago. Okay, so we've got BC, tick. Now let's go AC. AC is going to be 2 times DF. Again, the midpoint theorem. And finally, remember this statement and reason thing is important. So we've got AC. Finally, AB is equal to 2 times EF. And again, the midpoint theorem. Okay, and now, not difficult at all, the perimeter of triangle ABC is equal to AB plus BC plus AC. So, maybe we should write all of that down. AB plus BC plus AC, which is essentially 2 times AB was EF plus 2 times BC, DE, plus 2 times AC there, DF. I should have kept it all in the same order. Okay, and then we just need to work it out. I'm going to just write it over here for space reasons. So 2 times EF, so 2 times x minus 5, plus 2 times DE there, x plus 3, plus 2 times DF, 2x plus 2. Okay, and in this case, the question would probably say, and a test, the question is always a little bit longer, in terms of x, and so that's okay, that we've got all these x's in our answer. 2x minus 10 plus 2x plus 6 plus 4x plus 4. And then we just group our like terms, and we can answer this thing. Nice and easy. Okay, 2x plus 2x is 4x, plus another 4x is 8x. And then we've got minus 10 plus 6 plus 4. So that's minus 10 plus 10, which just goes away. So there, a nice neat answer, 8x.